So title of the invention is Customized Haptic Control Circuit for VRML Object. I have filed this application on 22nd February 2019 and it was published on 15th of March 2019. The name of inventor is myself, Dr. Deepak Shirbhate. Along with me, there is another inventor, that is my guide, Dr. D.S. Ingole. So this is the abstract of the invention. The present invention relates to customized haptic control circuit for VRML object. The proposed invention is a customized haptic control electronic circuit designed specifically to control VRML object in real time. For real-time haptic control of VRML model, MATLAB script has been used. This script provides access to Bluetooth module. The proposed circuit comprises of 9-volt battery, 5-volt regulator, microcontroller, that is PIC, 16F72 PIC, 18F2250, ADXL chipset, 335/345 chip, USB to serial cord, Bluetooth module, and PC laptop. Following invention is described in detail with the help of figure 9 of sheets 5 showing hardware setup of customized haptic control for VRML object, and figure 10 of sheet 5 showing block diagram for haptic control of VRML desktop lamp. So there are 21 pages and there are 7 claims that we have filed during our patent application. So this is actually the VRML lamp. VRML actually stands for Virtual Reality Modeling Language. So I have created this VRML lamp using solid modeling software like say AutoCAD or Creo. Then I have exported this particular model into wave authorizing tool like say Vivity Studio. Vivity Studio is also called as Flux Studio. So it is a wave authorizing studio, and it is a shareware software having no proprietary. So there actually I have assigned some sensors, that is the interactivity, to this VRML lamp. Now you can see that with my mouse movement I can rotate the arms of the VRML lamp into 360 degree of rotation. So there are 2 arms. One is the lower arm which is attached to the base with the help of one spear sensor. Then there is a first arm, and then there is an envelope. So everywhere there is a spear sensor. So all the joints are having spear sensor, and I have created an illusion of on-off circuit, actually on-off lamp, using the color interpolation. So actually there is no on-off condition, but with the help of say color interpolation we can create the illusion of on-off. So in this way I have created this interactive VRML lamp. So in the absence of this circuit, that is customized haptic control circuit for VRML object, we can operate directly this lamp with the help of our mouse, and we can operate this particular lamp in the modern VRML player like say BS Contact. So this is the view of the BS Contact player, and I am operating this in the absence of the mouse. So this is the actual setup. Means in the absence of the circuit we can operate like this. Now in the first examination report, that is FER, it was stated that the subject matter as in claims 1 to 7 lacks inventive steps in view of the following prior art documents. There was 2 documents which were cited, that is D1 document which was having a title utilizing image based light solutions for augmented or virtual reality, and then there is another document, that is D2 document, which is bearing a number US patent 9984506 B2, having a title stress reduction in geometric maps of passable word model in augmented or virtual reality system. So these two were the objections which were raised by the examiner in the FER, that is first examination report, and accordingly I have submitted the justification to the every point that they have raised. So let us talk about the D1 document, which is US, that is US patent 20150302659A1, which is having a title utilizing image based light solution for augmented or virtual reality. So this invention presents an augmented reality display system comprising a passable world model data, comprises a set of map points corresponding to one or more object of the real world. So in this particular patent, actually there is augmented reality and there is virtual reality. So actually what happens that there is some objects in the uh, in the in the real world, and the system is capable of mapping those objects, and it is transferring those objects into the virtual reality system. So this is a mixture of the virtual and augmented reality. The augmented reality system also comprises a processor to communicate with one or more individual augmented reality display system to pass a portion of passable world model data to one or more individual augmented reality display system, wherein the piece of passable world model data is passed based at least in a part on respective location corresponding to one or more individual augmented reality display system. So here actually the objects from the real world are passed to the virtual reality system. So this is a mixture of augmented and virtual reality. Then there is another document, that is stress reduction D2 document, which is having a number US 9984506B2. Stress reduction in geometric maps of passable world model in augmented or virtual reality system. This invention represents an augmented reality display system comprises a passable world model data, comprises a set of map points corresponding to one or more objects of a real world. The augmented reality system also comprises a processor to communicate with one or more individual augmented reality display system to pass a portion of passable world model data to the one or more individual augmented reality display system, where the piece of passable world model data is passed at least in part on a respective location corresponding to one or more augmented reality display system. So now in our invention, actually with reference to the cited patents, that is D1 and D2, we submit the following clarification. We neither claim for invention of augmented reality display system nor did the processor control augmented reality display system. In our invention, the world model data is not passed to the augmented reality display system. Whereas in our invention, the objects and scenes are built by using graphic software, and thereafter all the objects and scenes are visually simulated by imposing limits and constraint. So this is actually you can say inventive step So whereas in our invention the objects and scenes are built by using graphic software, thereafter all the objects and so whereas in our invention the objects and scenes are built by using graphic software, thereafter all the objects and scenes are visually simulated by imposing limits and constraints. Our invention, in addition to this, predetermined virtual sensors are embedded in the scenes and integrated with the objects. Finally, all the objects and additional sensors are immersed in the scene and virtual environment is simulated. This happens without interaction of any hardware. So we have created actually the model separately with the web authorizing tool. We have applied the sensors and without using any hardware you can actually control the object. Now this particular hardware is created separately for this particular object, and that's why we have given the title Customize Haptic Control. Also the present invention relates to Customized Haptic Control Circuit for VRML object. The proposed invention is Customized Haptic Control Circuit designed specifically to control VRML objects in real time. For real-time haptic control of VRML model, the MATLAB script has been used. This script provides access to Bluetooth module and enables to design circuit and automatic execution capability. So it is this type of the invention. In the cited document D1, the inventor have nowhere mentioned about the use of any tool or software which provides automation capability to the invented system. And this one of the distinguished attempt of our invention. So we claim the method for haptic control of VRML objects and user movement within the confined region of its operation in real time, comprising of following steps: immersing of objects or solid models in virtual environment, animating the individual objects and virtual environment, synchronizing the movements of object in virtual environment, assigning the sensors to interact with the objects and virtual environment, writing the script for given instruction to the design haptic control circuit which is used to control the objects or virtual environment. So this is sheet 1 of 5, that is figure 1. So figure 1 of sheet 1 shows virtual desktop lamp created using virtual reality modeling language, where 1 denotes the neck joint, 2 denotes the arm joint, 3 denotes spear sensor, that is base joint, 4 denotes red switch touch sensor which will make the condition of the lamp as on, 5 will switch the condition of the lamp to off mode, and 6 denotes the color interpolation. Then this is sheet 2 of 1, which is showing the 2 different color, that is on and off. In the black and white it will not be that much distinctly visible, but in the color there will be white and yellow color. Figure 3 of sheet 2 shows desktop neck rotated in all 360 degree with the help of spear sensor. Figure 4 of sheet 2 shows desktop lamp different arm positions. 7 denotes key control panel, 8 denotes X-up, 9 denotes Y up, 10 denotes Z up, 11 denotes lamp on, 12 denotes X down, 13 denotes Y down, 14 denotes Z down, 15 denotes lamp off, 16 denotes all our switches, 17 denotes microprocessor or microcontroller, 18 denotes Wi-Fi module or Bluetooth. This is a remote control unit. Then 17 denotes microprocessor, microcontroller, 18 denotes Wi-Fi module, 19 denotes ADXL series chip, 20 denotes battery, 21 denotes push switches, 22 denotes pivot arm. Figure 7 of sheet 4 shows modified block diagram of a remote unit where 17 denotes microcontroller, 23 denotes selector switch, 14 denotes pivot arm 1, and 24 denotes pivot arm 1, and 25 denotes pivot arm 2 or pivot 2. 17 denotes a microcontroller or microprocessor. This is a figure 8 of sheet 4 of the electronic circuit. 26 denote battery supply, 27 denotes power supply, 28 denotes Wi-Fi circuit, 29 denotes motor drive, 30 denotes motor, 31 denotes switches, 32 denotes lamp. Figure 9 of sheet 5 hardware setup for customized haptic control. 33 denotes 9-hole battery, 34 denotes regulator 5-volt, 35 denotes MCPIC, 16 that is a chip, 36 denote ADXL 335, ADXL 345 chip, 37 denotes USB to serial, 38 denotes Bluetooth module, 39 denotes PC or laptop. So figure 10 of sheet 5 shows the block diagram of haptic control of Vrml object where 38 denotes Bluetooth module and 40 denotes Vrml module. So initially we have to run the script which is in the MATLAB. So this is the live demo. So as soon as you will run the MATLAB, you have to locate the directory where all the files are stored. So from the current folder you can actually switch to the folder where the script is written. So I am switching to another folder, and from that folder I am actually running the script, that is devtest2.m. So it will actually run the Simulink script, and the lamp will be visible, and at the same time it will give you the choice of the connection to the communication port. So 2 ports will be visible, communication 3 ports as you can see, and communication 4 port is visible. You just select the proper port and ask the script to connect to the Bluetooth module. Now as soon as the script will connect to the Bluetooth module and it will start sending the signal, the lamp, the indicator on the circuit, that is customized haptic control circuit for the Vrml object, it will start blinking, and here you will see some you can say visual indication that the script is running and it has been connected. So this black spot will become green, because there will be, as soon as there will be movement of the hand either in X direction, Y direction, as you can see the black spots becoming green. So it is just showing the tilt of the hand in that particular direction, X, Y, Z direction, in the 360 degrees. So it is showing actually the sphere sensor and in which direction actually I want to rotate. So accordingly you can see that the lamp is rotating. Then I can tilt my hand and again I can control the rotation. Now you can see that there are 3 points. So they are actually showing you the joint. Actually, to simplify the circuit, what we have done is that we are selecting the sphere sensor one by one. So you know that there are three sphere sensor. One is at the base, second is in between first and lower arm, and the third is in between the envelope and the upper arm. So you can select a proper joint accordingly. Now I have selected the sensor in between the lower and the upper arm, and now I can rotate the upper arm and the envelope or neck joint together, because the second sensor is active. Now I am going to shift it to the third sensor. So I am actually trying to select the third sensor, which is in between the upper arm and the neck. Actually, I have wrongly selected. Again, I have selected the first sensor, but I am actually, my intention is to select the third sensor. Third sphere sensor. This is a middle sensor, middle sphere sensor between the first and the lower arm and the upper. And now I have selected the third sphere sensor, and now you can see that the rotation of the envelope is taking place only. So with the help of this particular sensor, I can rotate actually the envelope. So in this way, I can switch between all the three sphere sensors one by one. And here I can, with the disconnect, this is a DIS option, I can disconnect actually the communication between the script and the customized haptic circuit for Vrml object. So in this way, I can switch between the sensors, I can connect as well as I can disconnect. Now I want to just put the lamp in on and off condition, and for that there is separate buttons, push buttons provided on the circuit, so which will operate the touch sensor in the virtual reality. And you can see that the lamp is in the on condition, and with the another button, another push switch, I can make the lamp off. This is the off condition. So it is a just illusion. It is a color interpolation which will create the illusion of on and off. There is no as such on and off condition. So in this way, with the customized haptic control circuit, we can control. So we claim that customized haptic control circuit for Vrml object, which is operated via Bluetooth, having sphere sensors embedded in its arm and neck, comprises of remote unit, battery, main supply, power supply, Wi-Fi circuit, motor driver, microprocessor, microcontroller, switches, lamp, accelerometer, neck and upper arm connected with the sphere sensor one, which gives the degree of freedom to rotate neck with 360. Upper arm and lower arm are connected by sphere sensor 2. Lower arm, which in turn is connected to the base by sphere sensor 3, and lamp has touch sensor 4 and 5 to switch the lamp in on and off condition. Accordingly, as claimed in the claim 1, where the said haptic control enables user to manipulate the object interactively in real time Once operated, the user is capable of switching between different VRML sensors with the help of selector switch. The sphere's action is completely mapped with hand glow, which will put on user's hand. This enables user to operate VRML sphere sensors just with hand movements. Accordingly, as claimed in claim 1, whereas a remote unit there are 3 pivot arms corresponding to VRML sphere sensors, and there should be equal number of X, Y, Z switches corresponding to number of pivot sphere sensors used in the lamp assembly. Accordingly, as claimed in claim 1, wherein the said haptic control comprises of 9-volt battery, 5-volt regulator, microcontroller, ADXL, USB to serial cord, Bluetooth module, and PC or laptop. Accordingly, as claimed in claim 1, whereas all the movements of the lamp motor is provided for each pivot for driving these motors driver circuit is implemented, which is controlled by microprocessor or microcontroller. Accordingly, as claimed in claim 1, where in all activities of circuit board or assembly model structure are completely controlled by microprocessor, microcontroller, characterized in that Wi-Fi unit receives command from the remote unit for movement. Wi-Fi unit pass this signal to motor processor. Main processor analyze the received signal from Wi-Fi unit and take appropriate action regarding motor shaft or the action. Accordingly, as claimed in claim 1, wherein the said lamp assembly consists of lamp cap, lamp holder, and wiring system. So this is all about